Have you ever wondered how the servers that send out your spam emails convert heat energy to electricity? An intriguing question, isn't it? It's a well-known fact that servers generate a lot of heat, but what if I told you that this heat doesn't go wasted? Yes, you heard it right. These servers have a unique way of transforming this heat into useful energy. So how does this fascinating process take place? Well, it's time to unravel this mystery. To understand this process, we first need to get a grip on the basics of energy conversion. Energy conversion is, simply put, the process of changing one form of energy into another. It's happening all around us and even within us. When you switch on a light bulb, electrical energy is converted into light and heat. When you pedal a bike, your mechanical energy is transformed into kinetic energy to move the bike forward. But how about converting heat into electricity? That's exactly where our story gets fascinating. In the world of physics, this process is governed by the first law of thermodynamics, which states that energy can neither be created nor destroyed, but only changed from one form to another. Now, let's dive a bit deeper into this. Imagine a pot of boiling water on a stove. The heat from the stove, which is a form of energy, is transferred to the water, causing the water molecules to move faster and faster until they start to vaporize. This is a perfect example of heat energy being converted into kinetic energy. But how do we get from heat energy to electrical energy? Well, it's through a process known as thermoelectric effect. This phenomenon was first discovered in the early 19th century, and it involves the direct conversion of temperature differences to electric voltage. In simple terms, when one side of a thermoelectric material is hot and the other side is cold, electrons move from the hot side to the cold side, creating an electric current. Yes, you heard it right. We can actually generate electricity from heat. And here's the best part. This isn't just a neat party trick. This process can be and is being used in many practical applications today, from powering spacecraft to recycling waste heat from industrial processes. Understanding this fundamental principle brings us one step closer to our main question. Now that we're familiar with energy conversion, let's dive into the heart of the matter: servers. A server, in its most basic form, is a computer. But not just any computer. It's a system that manages network resources, providing data, files, and services to other computers over a network. Whether it's a web page, an email, or a video stream, if you're accessing it over the internet, it's very likely coming from a server. But here's the thing about servers. They work hard. Very hard. They're like the unsung heroes of the digital world, tirelessly processing and transmitting data 24/7. This constant work generates a significant amount of heat. Why? Well, it's all down to the laws of physics. In a server, electrical energy is used to perform work, processing data. But not all of this electrical energy can be converted into useful work. Some of it inevitably becomes waste heat due to the inefficiencies in the energy conversion process. Now let's add spam emails into the mix. You know those pesky, unwanted messages that clutter up your inbox? Well, they're not just annoying. They also require a staggering amount of server resources. Every single spam email sent requires server work, from the moment it's dispatched to the moment it lands in your inbox. And with billions of spam emails being sent every day worldwide, that adds up to a lot of servers, working around the clock, generating a lot of heat. But wait, there's a silver lining here. This heat isn't just a byproduct to be discarded, it's a form of energy. And as we've learned, energy can be converted from one form to another. This brings us to a fascinating question. Can we turn this problem into a solution? Can we take this waste heat, this unwanted byproduct of server work and spam emails, and convert it into something useful? So these servers are basically heat factories, but how do they convert this heat into electricity? The secret lies in a device known as a thermoelectric generator, or TEG. Now you might be wondering, what is this thermoelectric generator? Well, sit back and let's delve into it. A thermoelectric generator, or TEG for short, is a solid-state device that converts heat flux directly into electrical energy. It's a bit of a marvel when you think about it. This conversion is based on a phenomenon known as the Seebeck effect, named after the German physicist Thomas Seebeck, who discovered it in the early 19th century. The Seebeck effect is all about how temperature differences in conductors can result in the generation of a voltage. In simpler terms, when one side of a thermoelectric material is heated, while the other side is kept cool, electricity is produced. This heat can come from any source, but in our case it's coming from the servers sending out those pesky spam emails. Now, how are these TEGs integrated into server systems, you might ask? It's an ingenious process, really. The TEGs are attached directly to the server's heat sinks. Heat sinks are components designed to absorb and disperse the heat generated by the server. When the heat sinks get hot, one side of the TEG gets hot too, while the other side remains cool, creating a temperature difference that generates electricity. This electricity is then used to power the servers themselves. It's a beautiful cycle. The servers generate heat, the TEGs convert that heat into electricity, and that electricity is used to power the servers. It's like a self-sustaining ecosystem but for technology. The integration of TEGs into server systems is a brilliant solution to two problems. First, it helps reduce the energy consumption of these servers, which can be quite high. And second, it helps manage the heat generated by these servers, which if left unchecked, can damage the server components. But there's more. The beauty of TEGs is that they're solid-state devices. That means they have no moving parts, making them incredibly durable and low maintenance. They can operate for years, even decades without needing any sort of repair or replacement. And because they're so compact, they can be easily integrated into existing server systems without taking up much space. So, let's recap. The servers send out spam emails, generating heat. This heat is absorbed by the heat sinks, which are attached to the TEGs. The TEGs, using the Seebeck effect, convert this heat into electricity. And this electricity is then used to power the servers. It's a closed loop of energy conversion and utilization. So, the heat from our spam email servers is not wasted but put to good use powering the very servers themselves. It's a testament to human ingenuity, turning a problem, in this case excess heat, into a solution. And who knows, perhaps one day, we'll see this technology utilized in other areas as well, from our homes to our cars, transforming waste heat into valuable electricity. This isn't just about spam emails though, the implications are far-reaching. Imagine the countless servers running day in, day out across the globe. Every tweet you send, every video you stream, every online transaction you make, they all need servers. Now think about the heat these servers generate. What if we could harness this energy? This is where the technology of converting heat energy to electricity comes into play. Not only can it revolutionize the server industry, but it can also find its footing in other sectors. Manufacturing plants, power stations, and even our homes generate heat that can be turned into usable electricity. This could lead to a significant reduction in our reliance on non-renewable energy sources. Consider the automotive industry. Cars, especially those with internal combustion engines, generate a lot of heat. Imagine if we could recapture some of that wasted heat and convert it into electricity. It could help power the car's electrical system, increasing its energy efficiency. Moreover, this technology could also play a vital role in space exploration. Spacecraft generate a significant amount of heat, which is usually dissipated into space. By converting this heat into electricity, we could potentially power the spacecraft's systems and instruments, extending their operational life. But perhaps the most compelling implication of this technology is its potential impact on sustainability and energy efficiency. As we grapple with the realities of climate change, the need for sustainable and efficient energy sources has never been more urgent. By turning waste heat into electricity, we could significantly reduce our carbon footprint. This technology could lead to more energy-efficient operations across industries, from tech to manufacturing, automotive, and even space exploration. It's an exciting prospect, one that could revolutionize the way we think about and use energy. So, the next time you get a spam email, remember there's a cutting-edge process going on behind the scenes. Let's quickly recap what we've learned today. We started off by unraveling the intriguing question of how spam email servers can convert heat energy into electrical energy. It sounds like something out of a science fiction novel, doesn't it? But as we dove deeper, we discovered that this is based on very real and practical scientific principles. We took a journey back to the basics of energy conversion, revisiting the fundamental laws of physics that tell us energy cannot be created or destroyed, only transformed. We learned that heat is a form of energy and, in the right circumstances, can be converted into other forms such as electricity. Then we turned our attention to the heart of the matter, servers. These technological powerhouses are known for generating a considerable amount of heat. In a typical scenario, this heat is seen as a byproduct, often wasted, and even a nuisance that requires expensive cooling solutions. But what if we could harness this heat instead of just getting rid of it? That's where thermoelectric generators, or TEGs, come into the picture. We delved into how these devices work, using the Seebeck effect to convert temperature differences directly into electricity. It's a remarkable process that has the potential to revolutionize how we manage heat in server farms and other high-heat environments. Finally, we explored the broader implications and practical applications of this technology. Beyond just spam email servers, this could be a game changer for a variety of industries. Imagine the possibilities, from reducing the energy consumption of data centers, to powering remote sensors, to providing a sustainable solution for waste heat recovery in industries. So, there you have it. The next time you receive a spam email, remember that there's a world of science and potential innovation behind it. There's always more than meets the eye, especially when it comes to technology. We've come a long way from our initial question. We've unraveled the fascinating process of how spam email servers convert heat energy to electricity, and I hope this has ignited a spark of curiosity in you. The world of energy conversion technologies is vast and ever-evolving, offering endless opportunities for exploration. So don't stop here. Dive deeper, question more, and let your curiosity guide you. Remember, even something as annoying as spam emails can lead to interesting technological insights. Let us know what you are most curious about in the comments section. Don't forget to like this video, share it with your friends, and subscribe to the channel. Stay curious, folks.